Hi everyone, this is going to be a video for what I'm going to call section 5.1, so chapter 5 from Big Ideas, lesson 1. It's not all of 5.1, it's just part of it, so that's why I'm going to call it lesson 1. So in this section we're going to be evaluating expressions with rational exponents. I want to just do a little review from the work we did before this, because this stuff you need to know to continue on into the evaluating. And I'll talk in a minute what we mean by evaluate. So for these review problems, see it says review from 5.1 introduction. First says direction, write each expression in radical form. So it currently has a exponent that's a fraction. A fraction we call a rational number. So these have rational exponents. We want to rewrite it as a radical. So remember the number on the bottom we said was the root. The number on the top we said was the flower. So we're doing the flower power on these. So the flower becomes the power and the root stays the root. So if I'm writing it in radical form, I need a radical. The root is 2. The power is going to be 1. The base is 16. So there it is in radical form. You could also write it as just the square root of 16. Because we normally don't write an exponent of 1, and we normally don't write a root of 2. So either one of these are correct. Here, my root is 3, and my flower, which will become my power, is 2. So I have a radical, root 3, base is 8, the big number always stays the same, and the flower becomes the power, so that's 2. Now I want to show you that there's different ways to write this. This is correct. This is also correct. Root 3, that's never going to change. The root will not change. The base will not change. But the way I write that power, there's different ways that are still correct. So root stays the same, base stays the same. I can put the power inside the radical here, or I can put the power outside. And this becomes important when we get to evaluating, which is what we're doing in this lesson, because oftentimes it's easier to evaluate if you do it this way. Oops, yeah. The other way I could write this is 8 to the second power is 64. So I could just write this as the third root of 64. So all of those are correct. Most of what we do today, we're going to use that one though. Okay, this is also review. Write each radical. So it already is a radical, and we want to write it in an exponential form. So we want it to look like these. We want each term to have an exponent that's a fraction. So this would be 128. The root is 3, and the power is kind of invisible, but it's 1. So that's 128 to the 1/3. This one I have 3 bases. I have 32 in the radical, x and y. This is how I do these. The root is 5 for everything. So I go ahead and I give everything a root of 5. And remember when we did these in the other lesson, we said every term gets a flower. And then the power, well, the power on the 5 I can see really easily. It's 5. The power on the y I can see is 6. The power on the 32 is that invisible 1 again. So this is rewritten. 5 over 5 is 1, so I could also say, I could simplify this one more step and just write that as x to the 1, y to the 6 over 5. But technically, since it just told me to rewrite, I was done right here. All right, now let's get to what we're doing in this new lesson. So notice this says evaluate, so it is not just rewrite. I have to simplify until I can't simplify any farther. So this is simplify, not just rewrite. Okay, the first step for simplifying these is going to be to rewrite it though. So the first thing I want to do is rewrite it in radical form. So the root is 5 and the power is 3. Okay, so that is rewritten. However, when we're evaluating these, I can't stop here. I have to go further. I want to think, I really don't want to do 32 to the third power and get this big number and then do a tree on it. It would be really ugly to do a tree on 32 to the third power. It's going to be a really big number. So on this one, I definitely want to put that power on the outside, just like we set up here. So this is fine. This is a rewrite. It's just that your power goes on the outside. Now, step 2 is I want to simplify this, which is just means do a jailbreak on everything inside these parentheses. So I'm just going to write my tree right here. I'm going to do a jailbreak on this, just this 32 to the 5th power. So 32 is 2 times 16, 2 times 8. If it's even, I just like to do this 2, 2, 2 thing all the way down. So there's my tree. So I can rewrite this as, notice I'm keeping it in those parentheses, keep it wrapped up. Don't forget that 3 on the outside. But the 32 is the same as 2 times 2 times 2 times 2 times 2. So that's 5 2s. Okay. Now, it's a 5th root, so I need a group of 5 for a jailbreak. So I have 5 2s right there. So everybody is going to break out. I'm going to end up with 1 2 on the outside of the radical. When everybody breaks out of jail, I don't really need the jail anymore. So this is now going to look like this. Still the parentheses, still the third power on the outside there, but what's left? A 2 outside an empty jail. Okay, not done yet. Keep going with this. What is 2 to the third the same as? That's the same as 2 times 2 times 2, which is 8. So all of this, 32 to the 3/5, simplifies all the way down to 8. So when I say simplify, this is what I mean. We didn't stop at the rewrite. We didn't even stop at the first jailbreak. We didn't stop until there was really nothing else to simplify. All right, let's try another one. First step, rewrite. And when I say rewrite, I mean as a radical. Root is 2, which is just a square root. I'll put the root though. 9 is the base. The power is 3. Again, 9 to the third power is a big number. I don't want to do a tree on a big number. So I am going to move that power to the outside. Now do a tree on 9. So now I'm simplifying, step 2. So tree that 9, it just trees into 3 times 3. So this is the same as, keep your parentheses, keep your exponent of 3, but in the jail I'm going to have 3 times 3. I need 2 for a jailbreak. I have 2. So who busts out? A 3. Jail is empty, so jail is gone. What's left is a 3 to the third power, which is 3 times 3 times 3, which is 3 times 3 is 9. 9 times 3, 27. So you can see these simplify down pretty nicely, right? Right to a plain old number. This is one for you to try, and I will tell you the answer you should get is 16. I'm going to do examples 4 and 5 in the next video.